Paco, how's it going?
Hey, Joe. Thank you very much. Really glad to be here.
Yeah, awesome. So we're at I think it's the AI Quality Conference in San Francisco. So
I'm thrilled. First one in person, and Dimitrios and crew have really pulled off a great show.
yeah, absolutely. So yeah, shout out to Dimitrios Brinkman and the MLOps community. Did a fantastic job with this event. So yeah, and I guess we're both giving talks later on today, but I figured let's. So we met. I think it was actually last week.
Yeah, exactly.
In a meeting. So I was like, been a podcast. But anyway, for people who don't know who you are, do you want to give a quick intro?
Sure. Yeah. Let's see. I've spent about 40 years being really interested in machine learning. And so I did that for grad work decades ago. And it's been a really interesting journey because for a long time, nobody cared. So I went off and did network engineering and cybersecurity and, other engineering work. And then eventually, people started caring more and more about data. I got calls that were very strange back in 2005 and got ideas bounced off me and then ended up being a guinea pig for new things being launched called AWS.
Okay.
And so I did a lot of work early on in cloud, and our team was running into some bottlenecks with workflow orchestration. So somebody suggested this new open source project in December that had just been launched called Hadoop. So our team was really early using AWS and then running Hadoop on AWS. And eventually we fixed some bugs in Hadoop so it would run better on EC2. And we became case study for what is now Elastic MapReduce. And I mean, this is all, archaeological ancient history. But I've been around since doing big data and data science on cloud was kind of a new thing.
Yeah. Yeah, I think you're kind of one of the OGs. And I came to realize too in our conversation that I think I've very likely read your writings back when I was a teenager.
Oh right, yeah, we were exactly. We were rolling back to Boing Boing and Factsheet 5 and
Mondo 2000, Wired.
Yeah,
I think yeah. So I mean that was the other part because I think it was
that was fantastic.
I think it was Scott Harrelman who introduced us.
Yeah.
He's like, yeah, he knows a lot about graphs. There's OG in the ML space.
Absolutely.
And I was like, yeah, but I think I've seen your name around a lot. And I was like, where do I know his name from? It's like Obi-Wan Kenobi in that Star Wars where he's like, that's a name I haven't heard for a long time. So yeah, you have a very, very storied, but I think very cool history.
We were actually doing chatbots back then. Did you know?
I didn't know that.
Yeah. So we launched a catalog for different zines and subcultures in late '92. It was on Gopher.
Oh yeah, I remember Gopher. Yeah.
Credit card over Gopher, which was kind of a weird thing.
Yeah.
And of course we evolved into a website as we could. But yeah, long story short, just a couple years in, a friend of mine, Robbie Garner, there was some chatbot competitions back then, early mid-'90s. And so we kind of sponsored Robbie and worked with him a lot. And we built out a catalog chatbot for e-commerce. This was 95-ish.
Okay.
And so it's really interesting now seeing how chatbots have, evolved into something ginormous compared to the tiny little sliver that was going on back then.
What was the impetus behind the chatbots back in the 90s?
Partly just because everybody was figuring out, hey, we've got internetworking, we've got, cool stuff we can do with the internet. How can we push this? And there were a lot of forums emerging, MUDs and Moos were kind of a thing for 5 minutes.
Yeah.
And so we're like, cool, why can't we just put some kind of crazy little agent in there and have people talk to it? And it was entertainment. People could actually shop and go to the catalog through it, but mostly people were doing it for their own purposes, just to kind of, have a shoulder to cry on or someone to tell them jokes.
That's interesting. I remember early IRC, there were some bots,
exactly,
quote unquote bots that you would have. It was one kind of heuristic based. What were the bots back then? Were they sort of intelligence based, or were they more?
I mean, usually it was typically more rules based. We did a platform called JFred that got used in some schools and whatnot. Actually, sorry.
Good noise.
There used to be competitions. There was something called the. The Loebner Prize was a Turing test for chatbot creators back in the 90s. And Robbie won it he took first place a couple times. And then Robbie and I actually did a Turing test on live TV. Ever heard of a show called Tomorrow World? James, what is his last name? There's a really famous science show on BBC called Tomorrow World. and James Burke was the guy who came off that.
Oh, okay. Yeah.
And so anyway, they're just like, hey, we want to do a Turing test, but on live television. And we're like, okay. And so the network engineering on that was actually pretty horrendous, but we actually pulled it off. It was
No
really
way.
fun.
And
And this was like 97. So, I mean, this is ancient history.
What was the verdict of that? Did it pass the Turing test back then?
Well, you know, the thing was they had a lot of different science fiction-y people, like the guy who played the evolved cat on Red Dwarf.
Okay.
He was one of our judges. Philippa from BattleBots, she was also, we
No
had
way.
a bunch of like celebrity judges. And in some cases, actually, there was an article in UK Telegraph. We actually scored kind of like record levels for confusing the judges at the time.
No way.
But I mean, back then, like I say, it was ancient history.
Yeah.
Stuff is so much better now. But it was kind of fun seeing this evolve.
What do you think about the chatbots now?
I think that chat over the years, I mean, I've seen different waves. So, like, I got a first dose of this in the early 80s. I was in grad school at Stanford, AI grad school, whatever.
Jeez, yeah.
And seeing what people could do with, like, ELIZA class stuff, which was pretty simplistic. But then a different wave of this came along in the mid 90s because we had more sophisticated systems. We could throw a lot more, like, rule processing and whatnot at it. And so we've seen waves grow. And obviously now, of course, LLM-based chatbots, different agents, it's getting really sophisticated. There was kind of an intermediate generation as well, which would be more like early aughts. There was kind of a wave. I think that chat, as I've seen it, in general, is a very seductive topic. Like, people are like, oh my God, I can talk with something. It must be thinking.
Yeah.
And like, I think the problem is a lot of people conflate the idea of language, thought, and intelligence, and they're actually three completely separate things. And language is not necessary for complex thought, and thought does not equal intelligence. So I think that's a nuance that gets lost to a lot of people. But that's why I think chatbots are really seductive, because the moment they see that, they're like, oh my God, I'm losing my mind. It must be like hyperintelligence or something. And it's not.
That's interesting. Like my kids, when they first tried, my favorite talk I gave last year in 2023 was actually to my kids at that time, 6th grade class.
Wow.
As they were graduating, and I came in to talk about AI,
Yeah.
right? So and I was like, so what do you think AI is? Like, oh, it's going to take over. I was like, what does that mean to you exactly? So I was like, okay, so there's my phone has ChatGPT on it, and the kids are like, oh, I've heard of that before. I'm like, okay, let's test this out. Let's play with it for the next hour, right? And I think the kids came away with a good understanding of sort of the boundaries of things, and hopefully demystified it, because I think they have this kind of mix of Futurama and like Terminator in their head of sort of what this is all going to look like. It's hard to know which, but I don't know what. So like the current generation of LLMs, I was actually just at a talk down the street at another company, and they're like they do like AI enabled or I guess ML powered search for BI and stuff. I kind of cringe at the term AI being conflated with everything these days, but yeah, it's weird. But anyway, but it was interesting because I think we're at a AI equality conference, and that one was definitely a bit more of it's here, so we got to start using it. But where are you on the spectrum of I guess say efficacy or usability of these tools? Because you point out like language intelligence and thought, and these aren't the same things, but like. And you've thought about this for decades. So I would love to know, what do you think?
Well, it's really interesting. I mean, this level of models, it's very good at recognizing syntax and being able to generate syntax. And generative approaches have been around for a long time.
Yeah.
I mean, my grad advisor caught a lot of flack for doing generative work back with something called Eurisco back in the late 70s.
Jeez.
And so, I mean, there have been efforts at generative. And one of my favorite examples in NLP was actually generative work that Primer was doing during COVID to like reduce down all the latest COVID-related research so frontline workers could be armed before they go into the next shift.
Right.
I mean, there have been generations of generative. My thought is, though, like these models are really super interesting from the perspective of highly capable of recognizing syntax if you have a problem that's syntactic. Like if you have a business process, if you have a domain-specific language, if you have a controlled vocabulary, and in some cases, very much the case, law, like contract law, is a very constrained language, and it's mostly syntactic. I mean, there are very clear definitions.
Right.
So I think that like where you have that, then these kind of syntax engines are really good, but they're not necessarily reasoning. And so I see a lot of extravagant efforts toward, can't we just, get a lot of reasoning if we throw together a graph of thoughts or whatever? I mean, there are cases, there was a case published today about foundation models trained on biology being able to like speed up, ESM. I don't know if you saw that when that came out.
I didn't see it.
I think that where you can take and train models in a very specific domain and be very careful about how you're working with them, you can get a lot of great results. But it's not the kind of thing that's real general purpose.
Right.
And I think people are conflating the idea of reasoning. There are great tools that we have for reasoning and decision making. They're non-LLMs. I think hybrid approaches are really interesting going forward. And RAG is, I think, kind of a Band-Aid, but it's like repurposing recommender systems to try to make LLMs more grounded. And what we're seeing is there's a lot of lift of using graphs along with RAG. And that's an area where I'm really interested in. I'll talk a little bit about that today. But I think that at the end of the day, there's a really great talk that I point out a lot from Frank von Harmelen a few years ago, where he's describing how there's a pendulum effect and sort of the camp that does statistical machine learning, which is great. I love that. They don't talk with the camp that does symbolic reasoning.
Right.
Like they go to different conferences. And there's a pendular effect, like every 10 years it kind of swings back and forth. And right now we're coming off the zenith of the empirical side and swinging back more toward the symbolic side. But realistically, you want to see hybrid. You want to use best of both worlds. And I think that, like graph RAG is, well, graph RAG means like 5 different things, but like graph enhanced RAG is a really interesting way of trying to blend together best of both worlds. But I think that there's inklings of other hybrid approaches that are super fascinating to me. Some of the graph diffusion work, like in painting for connected data, is really interesting and getting some good results out now. Still researchy. Semantic loss functions also still kind of at research phase, but also using symbolic data to tie down how we train models. In general, I'm super interested in what's going on with probabilistic circuits, and I think there's a lot of road ahead. A lot of these are kind of mathy terms that are still in research, but very promising.
What are some of the big ideas from the symbolic field that you think are going to be coming back, maybe in vogue?
Well,
so to speak?
one thing is just, it kind of kills me, like right now with GraphRag, because there's all these libraries that are there's 3 libraries that are popular. People are rediscovering use of graphs, and they're kind of throwing the baby out with the bathwater. So, like, if you go and use like the default tutorials, they're just like, oh, we'll build the graph for you, and yeah, we'll just link it to DBpedia, and we're good. You can get your paper published. I'm being a little bit cynical there, but there's a lot of work that can be done with connected data and tying it, entity linking into things that are well known, that are identifiers, that are established. And I think that in the LLM space, people are kind of rediscovering tangential areas that have been worked out before without actually like going to those people and saying, hey, can we collaborate? So there's a lot of like reinvention of the wheel I see going on right now at early stages. But on the symbolic side, things you can do is, hey, if you're working in biochemistry, you know what, molecules are actually pretty well known. You can describe a molecule, you can tie it, and then you can inherit a whole bunch of properties and metadata and whatnot that you can use.
Right.
As opposed to like, let's just throw a bunch of text into a model and see what happens. So the symbolic side is a way of really leveraging, bringing in what we had prior.
Yep.
And bringing in a lot more structured sources. And I think there's a lot of room. Like I said, the hybrid AI approaches, I think, have a long road ahead.
That's interesting. I've been thinking about this a lot from the perspective of data modeling and text to SQL, and just some of the, I would say that there's definitely, it's interesting because I did draw the parallel between what the symbolic camp was doing and I guess the quote data modeling camp was doing in the world of data, but I think there's definitely some parallels. So it feels like the world's also swinging back towards, I guess, reconsidering data modeling because we forgot about it for about the last 10 years. And
yeah,
so
words like schema kind of get overused and ideas kind of get lost.
Yeah, well, you didn't need it for a while. I'm joking, but it was like, what was the point? It's just so easy to throw things into whatever storage mechanism you want and just query it. But now I think you're starting to see the side effects of that. But what's interesting is a convergence of now that you didn't have 10 years ago of like the quote data world, the software world, and then the the AI world. It's all coming together,
smashing together.
Yeah.
What do you think? I mean, I think like a lost art that's really salient, really important now is like domain modeling.
Oh yeah, big time.
If you're trying to understand data products, if you're trying to understand context in AI, all these kind of boil down to like how well do you understand what the different domains are that are in use,
Yep.
and do you mix expertise from different models? Do you do ensembles or a mixture of experts or whatever? But again, it's going back to like how can I tie things down in a domain? I'll quote Tom Smoker was using this. So I'll quote my friend Tom. Rice means something different if you're a farmer or a chef or like a university fundraiser. Rice means something very different.
Right.
So like, how do you have that context as opposed to just sort of like finding similarity on surface forms? How can you get into more depth and context? And that's where the symbolic side is good because you can walk chains of reasoning through a graph, for instance.
Yeah, I completely agree. It's interesting that graphs. It feels like, and you have a lot more context than I do, but it seems like today it feels like it's having its time in the sun again. Like,
Yeah.
I'm sure, but it felt like the graph community had always been sort of doing some awesome stuff, but also, at least from where I sit, which isn't the graph community, was sort of screaming at the sky, like, just turn everything to a graph and it'll work. And
I know,
like,
I know. It kills
that's cool.
Well, I mean, if you roll the clock back into the '60s, databases, Codicil,
Right.
even if you look at like real successes like IMS, probably arguably one of the most popular databases even today, even though most people don't know about it. But like your credit cards are going through massive IMS systems. But if you have like parent-child links in an IMS, you've got a graph.
Yep.
And IBM knew. I used to work for a guy named Jack Olson, who had led IMS for a while and led part of DB2 at IBM. And IBM knew that, like, okay, graph databases are a thing. We do this. It's really hard to get the right people trained on them. Like, there's only a certain, you can get certain people who are graduating and train them on this and make them work. Other people are just like give up because they run into dead ends. And so it was a very deliberate effort, as I understand, through Jack. IBM tried going the route of graph databases pretty early.
Yeah.
And then they realized, look, the breadth of the market working in these kind of technologies is going to be narrow. So why don't we put more rails on it and dumb it down? And ergo, that was the decision to go with SQL.
Interesting. I didn't know that.
Yeah. And I mean, SQL has a lot of guarantees. A lot of the early reasons for SQL were, if I'm a manager at a bank and I have to do compliance reporting, I have certain reports that have to be done or I lose my bonus. And if I'm a bank VP, that's a 7-figure bonus. What can I do to make sure I've got guaranteed times on reads and writes?
Yeah.
Earlier database systems did not have guarantees. SQL was the first thing where you could actually guarantee the runtime if you knew the compute graph. And so then as a bank VP, you're like, okay, now I can staff up my compute resources, I can hit my targets, do our compliance, and I get my bonus. And that was the whole reason SQL originally got adopted.
Interesting.
Outside of the intelligence community, but like for banking.
No way.
Yeah.
I did not know this at all. So how did that go hand in hand with the relational model then?
Well, I mean, yeah, so Codd came up with the original model, and it's really brilliant if you've never read his original paper from 1969, 70.
Yeah.
And then he spent the rest of his life like talking about how bad IBM had been to like bastardize it and make SQL. And he's right. I mean, the math is really beautiful what he was doing with projections of tables.
Yeah.
And SQL is really a bastardization of it, but it works. And it solves a lot of problems. But I think that there have been very brass tacks economic reasons why it was adopted, and a lot of it has to go with like, are executives going to be able to make their bonus? Can we train up a large enough workforce? On and on and on.
Interesting.
Graphs were something that were a bit more problematic because, in computer science, graph is like at the core, absolute core of all computer science theory.
Oh yeah.
And whether you're working with compilers or just really wherever, SQL engines for that matter, you're always working with graphs. But the idea of a graph database and a general purpose tool has been kind of exotic. Part of it is because you can get in such trouble. Like Twitter found this out, you have your social graph, and most people at Twitter back in the day would have had like 105 followers on average. And so you do your compute through hundreds of millions of people, or however many, and then you hit Justin Timberlake or Lady Gaga, right? And then suddenly, like, your algorithms are completely torn off. So you end up having to deal with these we might call them supernodes or other names for them, but you can get in real problems computationally with graphs if you don't understand the algorithms well. And that's where it does take a lot of sophisticated training to work through the problems. So they've been kind of exotic and marginalized. And then on top of that, there's also the semantic space, which is really useful, that kind of came out of origins, circa late, early origins of World Wide Web. And there was, work in the later 90s, mid to late 90s that led to more like semantic web kind of ideas. Also kind of marginalized because there's some real esoteric corners of it. And I love using RDF and OWL and all the rest, but you do need to have this learning curve that you get through. So I think, it's interesting now because there's such a bifurcation between here are the people who work with labeled property graphs and they're much more industry and much more application. Right. The people who work with semantic web and all that whole stack from WQC, and it's much more researchy. There are definitely ways of aligning it. But yeah, graphs are kind of having their day because we are finding that, for instance, wherever there's compliance, there's usually some kind of graph problem. For instance, if you're tracking money laundering at a bank, are you going to give credit to this new entity that's applying?
Right.
And then you trace back a couple levels. It's well, actually, this is a shell corp for a Russian oligarch, and if you do that, you'll be fined. So, and the same thing if you're I have a friend in Europe who builds out, certifications for ship captains, for LPG tankers. It's graphs, because to be able to get to that level of expertise, there's so many different routes, and the compliance regulations are so weird and arcane that representing a graph is your only hope of being able to automate this. So I think we see over and over, whether we're talking about pharma or finance or cybersecurity. Graphs are kind of having their day in the sun because we are recognizing more of a complex world and a lot more of a connected world, and this is just the way to deal with it.
So I guess to kind of bring it back to the conference here, because we're talking about AI quality. I'm not exactly sure what that means actually, but how do you know when you need a graph? How do you know that you have something where a graph is suitable to solve your problem?
Interesting, yeah. People who have worked in data are familiar with maybe a data lake idea, where you've got a lot of tables or maybe some semi-structured data, whatever. You've got a lot of different kind of data out there. Some of it connects together. Ostensibly, you should be able to query across different tables. There's some kind of foreign key. There's some kind of relationship that you can leverage. And the thing is that's great if you're doing reporting, what are my week-over-week statistics for click-through rates in my ad campaigns. Right. Okay, that makes sense to have a data warehouse, and we'll just run some queries. What if, though, you're dealing with data which is not so cut and dry, and you really have to do investigation? So, literally, if you are trying to track, a smuggling ring, and maybe they're smuggling arms across a border, or they're smuggling, for instance, one that just came up recently was really interesting. It was Russian tankers smuggling grain illegally out of Ukraine. And then ships are docking out at sea and transferring loads from a sanctioned country to a non-sanctioned country.
Right.
And things like that, where you've got really intelligent bad actors who are trying to be obscure. You're not going to find them by doing a SQL query.
Right.
Okay, you're going to have to investigate through a graph. And so the more complex the world becomes in terms of cyber attacks or sanctions compliance, are a couple of really good areas for this, or just really hard problems in terms of climate science and trying to understand what's going on in agriculture, why are things changing. These are connected problems, and that's where graphs come in.
Interesting.
And unless you have the fluidity of going through a graph, it's going to be problematic. You could use relational to traverse through a graph, but there's the problem of self-joins generally.
Right.
Relational tools are built to join from one kind of table to another and elements across. Self-joins within a table brings relational models to their knees usually. So when you have to do path traversals in a graph, you'd have to probably do a lot of self-joins in a table, and that's where the relational models just fall over. They're not built for that. So that's kind of the parameters. And again, what kills me is I've been in this area, and I know that there are great applications. A lot of them, people can't talk about it. We had the Knowledge Graph Conference in Manhattan last month, and I was talking to people who are running large graph practices at different financial houses, and they're really into it. totally can't talk about it, right? They were not presented in the conference. So people come and look at these conferences and go, well, there's not really any application that I see. It's like, yeah, the DoD people can't talk, the finance people can't talk. Ugh.
Does that make for an awkward conference where you're all sharing enthusiasm for discipline, but you can't share details of your enthusiasm?
Exactly, yeah. How do you get the use cases elevated? Yeah, it's interesting. I think, saving grace there, well, pharma has definitely been able to talk about more of this, and there have been a lot of big wins. Benevolent AI sort of pioneered the idea of like a golden triangle in pharma research for drug repurposing. So the idea was like, I take 100 million documents off of PubMed or whatever, some sources, and I look for mentions of molecules, and I look for mentions of diseases, and I look for mentions of genes, and that's my golden triangle. And now if I rinse, lather, repeat hundreds of millions of times, suddenly this probabilistic graph starts to build out. And, the drug companies have been leveraging this for a while, AstraZeneca and Novartis and others. That's an area where like graphs really pay off. You can find out that, we do know in the literature there are some effects we could leverage, repurpose this drug. It's a weight loss drug, we can use it for heart disease. So a lot of that has really paid off. I think we're finding other areas where people can talk about their graph work. Lately, I've been getting up to speed on sanctions compliance.
Oh, interesting.
And most of that is open data. Like the global identifiers for companies because of the 2009 financial crash, that's a thing.
Oh, okay. I didn't know that.
And like, who are the people, what do you call PEPs? Political exposed persons, there's a short list, right?
Okay.
And like, who are the oligarchs who are actually sanctioned, or their companies that are sanctioned? And you start seeing all these different data sets accrue, but they're all basically linked, right? It's a very obvious case for a graph.
Right.
And this is a case where there's a public need to stop, like for instance, illegal fishing that's being conducted at industrial scale. There's a public need to stop like arms trafficking or people trafficking. And I think the open data is kind of a saving grace along with these really thorny problems, which are very unfortunate. But it's how we're trying to resolve them.
That's super cool. And then, you're working at, where are you at right now?
I'm at a company called Sensing.
Yeah.
We do entity resolution. I'll talk about it later today. Sensing, you probably have used it in one way or another, but you probably have never heard of it. Company's been around for like 20 years. Did you ever see the movie 21 about the MIT card counting?
Yeah. Yep.
Yeah. So Sensing was actually part of the tool chain to catch the students. They've been around for a long time. And it's used, majority of voter registration in the US uses this. Tax agencies, police departments, counterterrorism, cyber, but also bank, like anti-money laundering, KYC regulations. Also just like marketing. Like, hey, I've got, hundreds of millions of different records in here, but can I deduplicate it in a smart way?
Right.
So yeah, we do a lot of work there, which is really kind of more of a data quality argument, if you will. And it's cheaper to do that upstream than it is downstream. And it gets used a lot for knowledge graph construction and updates. We found that actually a lot of the customers were adjacent to some graph practice. And about 60% of what we do is in air gap environments. A lot of it is government or banking. But more and more, we're seeing, like I say, really open kinds of use cases leveraging open data.
Interesting.
So obviously, there's a lot of interest in using LLMs and leveraging graph-enhanced drag, and that's kind of like the thing that's pulling this. But it is ultimately it's a data quality or AI quality kind of issue.
That's interesting. What back to LLMs too? Like, what do you think is driving the interest in using knowledge graphs alongside LLMs?
Yeah, it's interesting. I mean, so obviously, machine learning models tend to generalize. This is why we have loss functions.
Yeah.
This is the magic trick that they do. No free lunch, but they do it in very interesting ways. And large models can generalize some really amazing things. But generalizing is also a way of kind of, shall we say, making shit up.
Right.
And so, this term hallucination has been introduced for the past few years to say, hey, the model came up with stuff because you asked a question and didn't really have a good answer, but here's an answer. And I mean, that's actually what a lot of this class of machine learning was developed to do.
Yeah.
And it can be leveraged because now you can find perhaps things you never would have thought of. Like my spouse had a bad day at work and came home and said, I need gin and I need sake. And, I was watching the news and I was like, gin sake. Cool, I'll make up a new cocktail. And I went to ChatGPT and I made a gin sake recipe, which I thought was like, this is a good use for a chatbot.
Was it a good drink?
Yeah, it actually was. Yeah.
Damn,
I love it. A little bit of elderflower, and some simple syrup. But,
Okay.
And so, I think their ability to kind of make shit up is really interesting. But obviously, if you're in a mission critical application like in healthcare, you don't want your models to just make shit up. So you want to ground them, right? You want to really leverage. And also, training models or even fine tuning models is expensive. But can you put something in at the very last minute that's my latest and greatest data and ground on that? So that's where RAG comes in. RAG is retrieval augmented generation. It's kind of repurposing recommender system technology.
Yeah.
Like, let me find the right embeddings, order them in an index, and I'll throw that to my LLM to sequence out the answer and make it glossy and look nice. The problem, though, is like that kind of retrieval technology is similarity metrics are really shallow. And so, like, again, going back, like rice means something different to a farmer or to a chef. Can you get past the shallowness of similarity metrics? Can you go and do a traversal? Like, I know that a cat and a kitten and a leopard and a lion are related. Like, linguistically, they're completely different words. But if I have a graph where I can look at hypernyms and hyponyms like I would in a thesaurus, like here's things that are related that are more general class or things that are more specific class, or like here's a synonym. If I can walk that tree a few hops out and come from a few starting points that I've pulled out of my prompt, and I can start to see where that graph starts to connect. And then I can go back in and do some graph analytics, like do some centrality measures. Then I can really figure out what the hell is going on in this prompt,
Right.
and come out with something that nearest neighbor similarity metrics would totally miss. And I will go to, I think one of the best talks about this, John Stevens gave a talk from AbbVie, the pharma company, at Knowledge Graph Conference in May. And I really loved it because they were using LMs, they were using RAG and graph RAG, and they'd done a lot of empirical studies of like, where's the benefit of using a graph with RAG? And their use case was, in pharma, you have molecules, but then you have the drug names, and you have clearance to use a particular drug for a particular kind of application, disease or healthcare.
Yeah.
And so you end up getting these really weird, and even the people inside the company, they don't know what the molecule is versus the 5 different trade names. So they're actually using these models to like, can we keep track of our own stuff? And they had a graph to describe that, but they found a lot of lift by using the graph to augment what they're doing with RAG. Because otherwise, those non-obvious associations, which are multi-hop associations,
Right.
they get lost.
Interesting. But if they just use a graph, would they have solved that problem as well?
That's the question is like, could you have just done some question answering on a graph? Did you actually need to have an LLM?
Right.
It's kind of expensive. And I think long term, yeah, I think the answer might be, I mean, have you seen any of the graph diffusion work? Maybe you can kind of drill it down into that.
No, let's talk about that.
So like diffusion is like in painting, like DALL-E 2. So like if I have an image that's partially corrupted, can I fill in the parts that are missing?
Yep.
Because I've trained on basically I've taken a good image, I've knocked out parts over and over until it's noise, flip it around and train on that sequence. So for in painting, you're kind of reconstructing an image back into a whole. Or maybe you've done some kind of training between like a set of words or phrases toward like elements in a graph scene, in a image scene. So in painting is kind of like, how can we reconstruct an image? What people have been working on though is like, can we use the same principle of diffusion to sort of do in painting for connected data?
Oh,
like if I have a schematic for a skyscraper and I expect certain patterns and I'm going through, can I find parts that maybe there's something missing and like suggest what should be there? That's one of the more interesting applications I've seen of this. Because at the end of the day, it's, in painting works because images are basically sequences, one way or another. And if you can take and like tokenize and then make a sequence out of schematics that follow ISO whatever, then you can ingest a whole bunch of really structured or really interesting data about how a plant works or how a skyscraper functions. What's the fire system? Where's the interconnects with the electrical system? And now we can take a look at that as a graph and start to fill in the missing blanks or suggest things. And so
Interesting.
if you're trying to catch bad guys who are operating out at sea, maybe you can start doing some sort of in-painting to fill in the blanks for the investigation. No LLM necessarily involved in terms of like, I'm going to put this into a text answer in a chatbot. Instead, can I just start using the machine learning directly on the kind of data that I need? So the graph
Interesting.
diffusion, I think, is really interesting because this is where you can get into leveraging more of like question answer directly on the graph without having the more expensive LLM component on the end. There's probably going to be some large models involved in it, but maybe not quite as convoluted.
It'd probably make it a lot cheaper to train these models, I'm guessing.
Yeah. I
Yeah.
think. I mean, there's certainly, this is a general trend that we're seeing. Certainly it ticked up last year, but the idea of having smaller and more narrowly defined tasks and like training specifically for those. Usually more cost effective, usually better results. Have you ever seen one of my favorite papers in this area, have you ever seen epsilon ambiguity?
I've not.
To describe how models fail or not? It's out of York, and I'm blanking on the researcher's name, but out of York University in Canada. But it's really great because basically the premise was, okay, if we can do an artificial language and just come up with something as language, train a model on it, and then test on it. So we'll come up with an artificial language that has no ambiguity. And there are actually efforts to have something that sounds like English or French that has ambiguity. That's totally other thing we can talk about. But can I come up with artificial languages that have measurable levels of ambiguity? And what you find when you train large models on those and then test them is that there's a direct correlation between model performance, reliability, and the ambiguity in the source language.
Okay, interesting.
So, so I think that if you can really narrow what your task is and reduce a lot of the ambiguity in the problem statement and really narrow that focus, then obviously you're probably going to get better evals or be able to express them better. But you're really narrowing the ambiguity on the problem, and this is where the models can really shine as opposed to just kind of willy-nilly making shit up.
Yeah. That's really interesting. And what you were saying with the graph diffusion thing, too, is it got me thinking about imputation. Which is kind of a devilish problem and something that...
it's coming back. I mean, this is another thing that I really was stark to me. Have you studied like graph neural networks? Have you seen...
Only... Yeah, not in depth, I would say. Like I've read actually the graph neural networks. I thought all neural networks were graphs. Is that not true?
Well, yeah. I mean, you can make the argument that a network, a neural network is a graph. Well, there was an area of machine learning that was super popular, like roboclock back to like 2019, even into like early 2022. It was hard to get a machine learning paper published unless you mentioned those three magic letters, GNN.
Okay.
Like if you were trying to publish at ICLR or NeurIPS or whatever. So GNNs were really popular. And then, like all the work with LLMs took off, ChatGPT, and so everybody like dropped GNNs, and now they're LLM experts. What was really interesting was like Neo4j, graph database company.
Yeah.
They went out and they commissioned a study in industry. They're like, wow, everybody was doing GNNs. There must be all over industry. Let's find these use cases. And they came back with even, I won't mention, but there was a company which was strongly associated, came back and said, no, we pulled the plug.
Oh, wow. Okay.
So this was around 2023, and the Neo4j study came out and said, look, we can't find any evidence of GNNs being used in industry. The next year, Spotify published, and they're like, we finally cracked the nut. We can monetize recommender systems for audiobooks, which had been really thin data, hugely problematic to commercialize before. But they use a GNN along with some very specialized work in LLMs, a two-tower approach.
Interesting.
And we've been working on this for a couple of years, and it works. And here's the lift. And it's sort of like, yeah, wait, didn't Neo4j ask you about this? And you said no? So I guess I will wrap this together. I will reference Luc Biawald from Weights and Biases had a great talk some years ago. there's inherent latencies. So like deep learning was published, 2006. There was a great Hinton paper about it. Nobody cared until the data set showed up with ImageNet,
Yeah.
2012, and AlexNet gets published. And so there's like this 6-year latency between the algorithm being published, which was going to be really spectacular, but nobody cared until they could get a data set that would prove it and show a killer app. But then there's this other latency because, okay, now we've got killer apps. For a large company to monetize that, they've got to hire some people. That's going to take a while. And they've got to get them going and prove it out with like the business use case. That's going to take some while. But here's the other killer part. It's going to take a little while longer before the people we hired who are really expensive are going to jump ship unless we let them publish. So it's usually an HR decision.
That's interesting.
And so there's this latency of like 2 to 4 years. Once a technology is proven, there's this latency of another 2 to 4 years before you actually get the commercial use cases to say, yes, we confirm this. And it's largely because of HR policies. And so you end up getting this cycle of like maybe almost 10 years from like algorithm that's developed, data sets prove it out, companies start going on it, and then companies finally let their people publish about it. And so in such a fast-paced moving world where there's just massive research coming out all the time, can we afford to wait 10 years before we get market validation? And it really distorts decisions, like I say, like how Neo got caught on the Spotify thing.
Yeah.
And so I think that's really interesting because there's really fascinating research being done in AI and a lot of things that I expect to see rolled out. I think there's obviously a lot of hype, but it's also really difficult to get the market validation and do the market research. And I think this is fascinating. I don't have a solution for it, but I think it's a good lens to keep in mind when you're trying to evaluate technology that some of the latencies are working against you.
That's a really good point, and I've never thought of that before. Was that the first time you had that realization? Or you've been around enough, you've seen this elsewhere.
I think that Ben and I were throwing that one about. That one came out recently. I think Ben Lorick and I were tossing that one back and forth.
Yeah.
But this was, I will definitely reference from the first AI conference in San Francisco. I think it was like 2016 or 2017, and Luke Biowald did a great talk back then about like latencies and proving out. So I'm just kind of riffing off of what Luke said.
That's fascinating. There's a lot to chew on there. I'm thinking about that, like you said, and I think I was like focused on. I was focused on something else. I entirely missed the GNN whole phenomenon. It's like you blink and it's just like, okay, I guess it was there, and didn't see it.
It does come back to the question you're asking, though. I mean, I think that there's a lot there about understanding patterns in connected data.
Yeah.
And being able to train them with deep learning and do something that's like topologically aware, geometrically aware. I think there's a lot of room ahead for being able to leverage that, and that's a different direction than using LLMs. They probably work well together. There's probably a lot of mix and match.
Right.
But I think for a lot of real-world data, we'll see this. It's expensive. It's hard. It takes time.
Yeah.
So it'll be a while before it really gets proven out, but I think there's definitely some road ahead.
Oh yeah, I was chatting with Andrew Ng over the weekend about this, and he was saying like, even to train a gig of data in the cloud's like, I think it was like $300 per gig or something crazy.
Crazy.
Because we were talking about, because he had this notion like data gravity is sort of a thing of the past when it comes to these models. Because like your egress cost, what is it per gig? Maybe 10 cents at most.
It's not that bad.
Then it costs you $300. It's like, who cares? Just put it on the best place to train it.
Yeah.
And do it that way. But then he's like, so the whole notion was data gravity for the clouds, which have traditionally been like a moat that's doesn't exist.
Compared to the enormous cost that people are paying to like train or
it's very negligible. Yeah.
Did you see the James Hamilton, the chief scientist for AWS? James Hamilton had a talk. I think it was at CIDR. I'm blanking on the title of the talk, but it was a lot of great numbers out of AWS, like large customers training models, how much that costs, what kind of cluster they use. That was a $65 million cloud bill. And this is the GPU cluster we ran for 3 months. This stuff is really expensive.
It's really expensive, and that's what I was thinking when you said with the graph providing a lot of the context and basically a lot of the shortcuts. It's like, do you need? I guess do you need as much power thrown at this thing? So I don't know. I guess we'll.
I do really wonder about that. I think there could be efficiencies by leveraging more domain knowledge. A lot of trade-offs there. But certainly, do you need to learn everything by generalizing it? through a statistically trained machine learning model? And the answer is probably no. There's probably a lot of stuff that you can grab a priori and really cut to a solution earlier.
Yeah.
And what that implies is there's a lot of money literally going up into carbon in the atmosphere, unfortunately.
Yeah, really. I mean, do you think, I mean, you mentioned kind of the pendulum swing from the statistical back to the symbolic. Do you think we're actually going to swing the other way and go kind of overweight on symbolic at some point?
I don't think so. I think that there's enough recognition of hybrid approaches, and there's enough people really, number one, funded to think in that way. I mean, it used to be that a lot of the semantic web stuff, it got a bit marginalized because it's kind of in corners of research, and there are people who have funding, but it's not the most interesting area of research for a PhD candidate to go into.
Right.
So I think though now, we are seeing a lot of the cost issues. Obviously, we can keep building bigger and bigger machine learning models.
Yeah.
At billions and trillions of parameters and blah, blah, blah. But at some point, you hit diminishing returns if that's being done in a naive way.
Yeah.
And whereas the hybrid approaches maybe can mitigate some of the costs, improve a lot of the quality and trust, or explainability at least.
Yep.
And a lot of these kind of things that have been cast aside but are really needed in production. And that's kind of where I would tie it back to like ML ops here is,
Right.
we can do a lot by training super huge models, but at the end of the day, somebody's going to be accountable. Somebody's going to care about the evidence. There's going to have to be a GDPR takedown somewhere, and you're going to have to redact data, and oh my God, what happens, and how can we explain it? So these things that have been quote unquote intangibles, I think are going to come back and bite us. So
I think you're right, and it kind of reminds me of what was it, Jared Diamond's book Collapse, where it starts off with a scene of Easter Island where everyone just kept building bigger and bigger statues. That kind of reminds me of the LLM race right now, where it's, then ultimately like caused the downfall of the entire island. They just mysteriously disappeared. I'm like, this seems anecdotally familiar.
I mean, I love to stand here and say, oh yeah, well, beyond a certain threshold, this many parameters and this kind of context window, it's diminishing returns. I don't know. I mean,
we don't know.
Anybody who does know. And to prove it out is actually really expensive, and maybe that's the point. It's like, maybe we should be exploring areas where we can actually prove them out, as opposed to just what if. And I'm sure that that'll be a natural process. I mean, right now there's a half dozen companies on the planet who are funding super high-end research, but how long does that go on?
Yeah, that's a good point. I guess kind of closing out, what are you most excited about over the next 5 years? I mean, you've been in this space for a very long time, and so you have a lot of context. No pun intended.
Oh yeah. I love it. I am super thrilled about some of what I see. I'm like work on approximation methods with deep learning. Anima and N. Kumar leads a team down at Caltech. They just redid weather models, climate models that run like 50,000 times faster.
Wow.
So if you're in supposedly the path of a Cat 4 hurricane, who do we evacuate? That's the question. And we're going to be seeing, unfortunately, a lot more of that.
Yep.
Being able to apply machine learning to knock down really hard problems like that are super valuable, super important, and making them so much more efficient. I'm seeing that in the real world, and along with it, applications in medicine, in biology. Obviously, we're here at an AI conference in San Francisco. Probably a lot of this is going to be targeted at, advertising or finance, hedge funds, whatever. Yep. But I do think in the real world, there are a lot of hard problems, and I think these kind of technologies are coming to bear, and that's what's exciting to me.
Yeah. I hope you're right, too. I mean, it's just kind of stuff I'd be excited about, too. It's just things that solve real problems. As talking to somebody the other day about it, and it's like, AI is going to allow us to do a lot of things. I'm like, yeah, I hope so, because we have a lot of things we need to solve.
Exactly. We're making them worse in a lot of ways.
In the process of making it better, supposedly, the training costs and everything, and the amount of pollution, it's insane. Well, cool. It's been fun talking to you. I think we'll have to have a separate podcast. I'd love to dig into your history on content and all the other stuff. I think you kind of live like this dual life, and I felt like I didn't have enough time. Just given we'll have to speak in a bit, but I'd love to have you back on. We could talk about content, because that was the other thing I was more fascinated by, the fact that you're kind of a guy of like two worlds.
I love learning, and this is a hard area to learn. Learning curves are horrible. Machine learning is hard to keep up with. It's a real struggle to do it year after year after year as things keep growing. And so, yeah, content has always been kind of a thing that I've been toying with. It's like, how can I teach better? How can I learn better? And I see that being really necessary. And I've worked at O'Reilly. I've worked in, leading some areas of content. And gosh, it seemed like we were going in great directions, and then it seems like things kind of fell apart. So I think there's a lot of room forward on doing really interesting content models.
Let's make that part 2 of the podcast. Cool. If you want to be back on, man, that'd be fantastic. So,
I love it.
Yeah. Awesome. Well, Paco, thank you. Thanks, dude. Thank you.